Welcome everyone to our continuation in the series of kinematics. Today we are going to uh, begin the topic of motion under gravity and move further. So in the previous videos you would have seen that we were discussing the applications of equations of motion in some situations which may come in some questions. So mainly we learned the equations x is equal to ut plus half at square. So in motion under gravity we are going to learn that we have to apply the same equations in the situations where gravity comes under play. So what happens now? So let us take a simple case, that there is a kid playing in the playground and he has a ball, and he takes the ball in his hand. Let's say the red dot represents the ball, and he wants to see that how high can he throw the ball in one particular try. So let's say he throws the ball upwards with a velocity u. So the question which comes to mind is that how would we evaluate or assign the acceleration of this ball during its motion. What is the acceleration of the ball during its motion? So from observation we know that the ball first goes up and it reaches some maximum height. Now that is what the kid wants to achieve. He wants to see that how high can he throw the ball, and then there is some other kid comes along and he also throws his ball in air with some different velocity. So in both the cases we know that the whole motion is simple, that the ball goes up and then it comes down. So how do we define the acceleration in this case? So as the ball is going up, we know that the ball is slowing down. So that means that the direction of acceleration is opposite the velocity initially, and we know that the acceleration which is actually downward in which is in downward direction is a permanent one throughout Earth. That means when we even take a ball and just drop it, then also it starts speeding up as it goes down. So the acceleration due to Earth is commonly called the acceleration due to gravity, and it is in downward direction. So let us say it is represented by A, and how do we write this in equation? So we know our general equation is x is equal to ut plus half at square. So this is what we want to do. We want to write simple equations for the cases when a particle is thrown under gravity and the motion is in a single direction. So this is one of the equations which we learned. So what we are trying to find is that how would these equations change, if at all, when we are dealing with this case. So the idea is that the equation whenever we are taking cases of uniform acceleration remains the same, and when the particle is moving under gravity, the gravity due to Earth is also constant during its motion. So that means that we can apply this equation. So that's the first part. Second, we want to see how to decide the acceleration of the body. So we know that the acceleration is in downward direction and it is a permanent one. So let us assume that the upward direction is positive and the point from which we are throwing the ball is the origin. So whatever height the ball reaches above ground, that can be x or that can be h. So let us say the height of the ball is x only, as we have taken in this particular figure. So x is the height reached by the ball at some t time, u is the initial velocity, Now the initial velocity of the ball is in the positive direction, which we have chosen, that's why it's positive. Time is t. Acceleration a is in downward direction. So this is the point which we have to keep in the mind, that the acceleration of the body is in opposite direction to what we have chosen. So it would be some negative value of some constant. That constant can be g. So the value of this g is calculated to be 9.8 meter per second square, and sometimes taken as 10 in some questions. So using a is equal to minus g in the equation, so this is the equation. So that means that all the equations of motions pretty much remain the same, except the fact that the acceleration changes from a to minus g, since the acceleration is in downward direction, and in most of the cases we would say that okay, the upward direction is positive. When we take upward direction as positive, then the downward direction is negative and the acceleration is in downward direction, obviously. So this becomes the equation. Similarly, all other equations change in the same manner. For example, v square is equal to u square plus 2ax. So the acceleration changes from a to minus g. So this becomes v square is equal to u square minus 2g x. So that means simply replacing a with minus g changes our equation for use in this particular cases. So let us take an example. So the first example is, what initial velocity should a ball be thrown upward with to reach a maximum height of 0.8 meter? So this is the same idea which we are considering, that there is a kid and he wants to throw the ball to a height of 0.8 meters. So he wants to determine that with what approximate velocity should I throw the ball so that it reaches the height of 0.8. So what equation should we use? So we are given the displacement which we are going to reach. We know the acceleration to gravity, and if we think about the situation, we can decide one more variable. The situation is that the ball has to reach the maximum height. So we know that in this particular equation, v square is equal to u square minus 2gx, the value v square represents the velocity of the ball when it has reached x displacement or x height, and we know that at 0.8 meter height the ball would stop. Why would the ball stop? Because it has at maximum height. So the final velocity would be 0. The initial velocity with which the ball is thrown is some u square and minus 2gh. So using the equation which we just derived, so if we solve with this further, u square is equal to 2gh and u is equal to square root 2gh. So that means that if the boy wants to take his ball to h height or throw the ball to a maximum height of h, then he must throw the ball with this initial velocity root 2gh. So after substituting the value of g and h in this equation, g is 10 and h is 0.8 and square root, the v would get 4 meters per second. So this would be our initial velocity with which the ball is to be thrown. Okay. So let us take our first question. A particle is thrown upward from a height of 15 meters with a speed of 10 meter per second. Action to gravity G is 10 meter per second square. Find the time taken by the particle to reach A, the level from which it is projected, and B, ground. So like in the last question, what we did was that we actually calculated the initial velocity with which we have to throw the ball to reach a height. If we take some time to read this question, then the question says that the particle is thrown upwards from a height of 15 meter. So that means we are already at some height. So let us draw a roof. So this is a roof or a cliff. So this is a cliff, usually called a cliff. So from this cliff there is a ball in the hand of the man, and he throws the ball in vertically upward direction. Now we know that the point from where the motion starts is called the origin. Is usually chosen as origin. So it is important to determine the point where the motion is starting from. So that we have already chosen. It's not necessary that the point from where the motion is starting is the origin, but we should have maximum information about that point. That is what I am saying. So let us moving on. The point from where the motion is starting, that is thrown upwards from a height of 15 meters. That means this point from where the ball is being thrown upward, this point is at a height of 15 meters. So this is provided in the question. Next, find the time taken by the particle to reach the level from which it is projected. So it is projected from this point, right? So let's say the ball is some blue color, its path is shown by blue colored, and the ball goes up like this and it comes down. So just as it reaches the level from which it is projected, that is the time which we want. So this is the time t1, and this is what we want. Further, when the ball goes further down, because there is nothing below it, it goes down, keeps on going down until it hits the ground, which is 15 meter below the point of projection. Next, in the second part, we want to find the time it takes to reach the ground. So t2 time. So this t2 time is from the point of projection. So this is what the question is asking us from. So we know value of G. G is some 10 meter per second square, and what we want is that we want the time. So again there are three equations that we have. V is equal to u plus at, which becomes v equal to u minus gt. V square is equal to u square minus 2gx, this equation, and x is equal to ut minus half gt square. So if we try to just take some time to think that not that which equation which we are trying to use, that is the important thing, but what is the significance of x in these equations. So what I mean by significance is, what does x mean? Does x mean what is the displacement, or does x mean its position? So the answer can be both. Sometimes it shows position, sometimes it shows displacement. But what is the correct answer? The correct answer would be that it always shows the displacement of the particle. And displacement from which point? Displacement from origin. So yes, we have to choose the origin of the particle. Only then we can go about using some equation. So when the equation is given like this, x is equal to ut minus half at minus half gt square, and the particle the particle's displacement is being measured from origin. So that means at t equal to 0, the particle is at origin. So that means this, where we started the motion from, is origin, and it goes up. So x is equal to ut minus half gt square. This is the equation which we want to use, and this is our origin. So the origin is always marked as x equal to 0 or simply 0 if it is a two-dimensional case. And what do we want? We want the time at which the particle comes back to the level from which it is projected. So when it would come back to the level from which it is projected, at what point do you see the particle? So by simple observation, it would be very clear that, and it would be, I think, easiest to observe of all the cases that the particle is at x equal to 0. That is, it is back to where it started from. So here we have drawn the path of the particle, showing that okay, the particle is going up and it is going down. So it may seem that the particle has traveled some distance horizontally also, but it is just to make the path of the particle clear to the reader that we have drawn it this way. Actually the particle would have gone vertically upward and returned in this particular direction only, but just to show that the particle is actually coming down, we are going in this way. So x is equal to ut minus half gt square, this equation which we have to use. So the particle would be at x equal to 0 when it is at the point of projection. So we would take x to be 0, x is taken as 0, and when initially the particle is projected in vertically upward direction, its velocity is 10 meters per second, and since it's upward, it's positive, so it's 10 t minus half of the action due to gravity g, which is 10 meters per second square. So on solving this equation, we would get the time t equal to 0. We put t equal to 0, then this equation would be satisfied, and when t is equal to 2 seconds, then also this equation would be satisfied. So that means that at t equal to 2 seconds, the particle would go up and come down. How t equal to 2 seconds? Just simple cancellation and calculation would give you this value. So how would the particle go up and come down? So at t, the answer is telling us that when t is equal to 0, the particle is at x equal to 0 itself. That means the particle has started moving from that point, and when t is equal to 2 seconds, the particle has come back to that point. So that means the time at which the particle is coming back to this point is 2 seconds. Next, when would the particle reach ground? So for that, what we would do is that we would consider the displacement of the particle. Yeah. So let us consider the displacement of the particle. So for B part, the displacement of the particle. Now when the particle is thrown upwards, it is moving in upward direction. This is my origin. When the particle starts traveling vertically upwards, x is positive since it is above origin. we have taken upward direction as positive and downward direction as negative. And upward direction is positive, that means whenever the particle is above this point, from the point of projection, from the level of projection, whenever at all the times when the particle is above that point, the displacement of the particle would be positive. As soon as the particle crosses this line and it goes below the level of projection, its displacement would instantaneously turn from positive to negative. So as it is going down, it is increasing in negative values from -1 meter, -2 meter, -3 and so on, finally to 15 meters. So eventually the particle would reach down to a position, or we can say displacement, of -15 meters from the point of projection. So the particle is finally at, or it has been displaced by a distance of -15 meter from the point of projection. So again, keeping it very clear that what x represents here, x can represent position as well as displacement in this case, since displacement and since initial position of the particle is 0. So we know that the displacement of the particle is -15 meter, and we want to find the time at which the particle reaches this point. So we would use this equation which we already used once. So we would write x is equal to ut minus half gt square. Now value of x is -15, initial velocity is some 10 t minus 5 t square. Since value of g is 10, g by 2 is 5. So this is our quadratic equation. So if we rearrange this equation, we will get t square, 5 is cancelled out, minus 2t minus 3 equal to 0. And solving this equation, we would get t is equal to -1 second and 3 seconds. So that means the particle at t equal to 3 seconds at t equal to 3 seconds, the particle would reach a position of -15 meters, that is at ground. So this is where the particle would reach after starting from the starting point. Okay, so let us jump to our next question. So in our next question, we are basically given a tower of height h, a particle with a speed u is projected vertically upwards. The particle reaches the maximum height in t time and the ground in into t time. So I would just visualize the situation for you. What is given to us is that there is a tower, and the tower has a height h, and a particle is projected with initial velocity u. That means it is somewhat same case like in the previous question which we get. Now the particle reaches the maximum height in t time. Now maximum height, what it means is that when we are throwing it upwards, then vertically upward we are seeing where the particle is at maximum distance from us, at maximum height from us, and not only from us, from ground. So in t time it reaches that point, that is the farthest point, highest point, and reaches the ground in n into t time interval. That means it's come back to the ground, not the point of projection but the ground in n into t time interval. We have to find the relation between h, n, u and g. We have to find a relation between the height reached, the n into t, that n variable, the initial velocity, and the action of gravity g. So this is what we are supposed to find. So let us begin. Okay. Okay, so we have a tower of a height h. This is the height of the tower from which we are going to project something, and it is going to come back to ground. We are throwing it up with a velocity u. It is going to reach some height, and let's say this would be some particular height. At the maximum height of the particle, it says that the particle takes t time. In t time the particle reaches maximum height. So I hope that is clear. And thereafter it continues its motion and comes to ground. So it says that it takes n into t time interval to reach the ground. So this n into t time interval, if the question does not make it clear to you, I would make it clear that this time interval is taken from the start of the motion. So that means we can directly say that the time at which it hits the ground is n into t. Now we have to find a relation between h, u, n and the action of gravity g. So let us start. So first let us try to find t. So the t time is the time at which it reaches the highest point. At highest point the velocity of the particle is 0. It is neither moving upwards nor moving downwards. So we take the final velocity of the particle v. Final velocity of the particle is 0, since the particle is at 0 velocity at highest point. Initially the particle has a velocity u which is positive. We take upward direction as positive, so we know u. So and let us use the equation v is equal to u plus at, and instead of acceleration we would use minus g, since action of gravity is opposite to the chosen positive direction. Now let's say final velocity of the particle, final velocity of the particle is 0. So let us take v equal to 0. U is the initial velocity, action of gravity is g, time is t. The time taken by the particle to reach maximum height is simply u by g. So we simply substitute the values in this equation v equal to u plus at. Final velocity is 0. At highest point the particle is not moving at all. So this is the value of t. We know t. Now you would be remembering that okay, we did the same thing in the previous question also. We had to calculate the overall time taken to reach this point, and we knew the maximum height, we knew the height from which it is thrown, and it becomes the displacement of the particle, that we know completely. So let us first write the equation which we are using. X is equal to u t plus half a t square. Now our direction is positive. We are calculating time from the point where the motion has started. So from the point where the motion has started, the displacement of the particle is actually downwards, since finally the particle is below the chosen point of origin. So we would say that the displacement of the particle is minus h. The initial velocity of the particle is upward, it is u. The time taken by the particle in completing the whole motion as per the question is a into t. So using n into t. So this is our time interval. Plus half a. The acceleration which we have is minus g by 2 into t, that is the total time taken n into t, and we square it. So this comes out to be minus h. We can substitute the value of t is equal to u by g. So when we substituted u by g over there from this particular equation, u square by g square n minus g by 2n square t square u square by g square. The 1g cancel out. This comes out to be minus h n u square by g minus n square u square by 2g. So we can easily see that u square by g can come out to be common, and negative sign can be taken inside. So this would come out to be h equal to u square upon g, and 1n can also be common, and u square by g, and this would be some, let's say we are taking 2 as a common also. So 2 I have taken in the left hand side of the equation, and this comes out to be some 2 minus n. And since we have taken the negative sign also, so there would be a negative sign too. So this would be n minus 2. So this would come out to be some 2h equal to n u square by g into n minus 2. So this is the relation which we wanted to find. So this is a small part of our lecture in the topic of kinematics, which was the topic of motional gravity. So in the next part we would cover non-uniform accelerated motion, and we would see how to use different equations in different cases. So thanks for joining. Have a nice day.